Okay, welcome back. Week 4 lecture, halfway through this 8-week course already. So um, this lecture will be fairly short because I've posted a 3-hour supplementary lecture on data mining and machine learning with R, um, delivered by a colleague of mine from the University of Central Arkansas. Um, I had him do it for another class, but it's voluntary, interesting. But this lecture, we're going to cover the objectives and then more specifically data mining versus data analytics, and then I want to go over the discussion question briefly and the research paper, and then we'll conclude. So from the classroom, the objectives this week, you should be able to describe data mining, identify types of data mining tools, explain how data mining and analytics work together, um, big data and how it assists sustainable networks. That one's kind of just stuck in there out of nowhere. This we could do a whole week on big data and sustainability research. But yeah. So number 5, explain how decision making can be helped by big data, and those last two just kind of get covered in the um, in the literature that you'll read. There's like six or seven articles in this week's materials, so check that out. Um, those are the objectives. So data mining. Um, uh, the definition from, I don't know, Techopedia, whatever it was, the practice of searching through large amounts of computerized data to find useful patterns or trends. Um, and you can, Google it. There's no ANSI standard definition for data mining. There's just an agreed upon term, and you'll see slightly different wording as you see it defined. But there are useful elements to the metaphor, somewhat. When you're data mining, you are combing through. You think of all the data you have, an entire data lake, um, and as you can think of that as the earth in a mine, a gold mine or a copper mine or whatever. And in data mining, you sort of go in and find the good stuff and identify it, and then move on to an industrial scale. So I like the metaphor of the prospector out in the old American West that knew he knew a little bit about geology and how gold um, was produced through natural occurrences in the earth, and how it's commonly found with different kinds of rocks, and then because of the way of physics, the way it interacts with other lighter materials in a river, there's very often gold to be found that has washed down through a creek bed, and that's where, if you ever heard of the Yukon gold rush, that was gold that was found by somebody panning, literally lifting some river gravel into a pan and swishing it around and finding little specks of gold, which are heavier than the other ones around it. So it's a decent metaphor for the data world, where you're not sure what you're going to find. You know what you're going to find something useful, and it could be that that they find silver instead of gold when they're out there panning. Um, so yeah, I like that metaphor. Mining operations back in the old West would start by prospecting. What are the prospects or the likelihood of finding sufficient useful material, and in our case, it's useful information that can be derived from the data. Yeah. So if a mine pans out, which means uh, it there was gold in them Thar hills. If a mine pans out, then industrial scale mining can begin with the sluices and the dredges that you might have seen in some of the historical um, works on industrial gold mining. They're still doing it today, up there in Alaska, particularly. I know I've seen it. So anyway, that's data mining, but specifically, data miners are looking for, and there's different algorithms based on the type of data that you're pulling together, but they're looking for there's clustering, or you look at it's called unsupervised machine learning. It's worth reading a paper on it if you're unfamiliar. You look at attributes of something. Could be a consumer purchase, uh, could be a student at at university or whatever. But you feed data um, into an algorithm, and it starts to show you how things are related. But it's not just like a good old fashioned correlation, which is still interesting. But clustering algorithms look at uh, all of the attributes, feature selection is another thing you'll see if you look into it. Looking for the way these things um, relate to each other in light of all the attributes that you have in your data file. So they're looking for the way things are similar, and then looking for deviations, looking for the way things are different and why. Um, uh, Classifying things into different groups using machine learning algorithm. That's more supervised machine learning. And of course, looking at the way data correlates, continuous variables correlate. Like for example, you can uh, with one line of Python code, you can draw a correlation matrix that looks at all the continuous data uh, in your data frame and draws a correlation between all of them. Um, so you can see which of your continuous variables correlate and which ones don't without even knowing the data and what it stands for, or what each attribute is, or what each column is. You can start to see what will correlate. And a lot of times it's obvious why they're correlating, because they are related. But other times you'll see a correlation that you weren't really expecting if you scatter plot all your continuous variables all at once. But that's the thing about data mining. It doesn't go in to answer a question like, what was the top selling widget this month, or anything simplistic like that. It's really more about exploratory data analysis, to see what the data might have, um, that you didn't know before. My only real project, doing big data analytics, was a text and file archive analytics. We brought back 40 terabytes of just files off of shared drive. Some of it was databases, so we pulled the data out of a database. Some of it was SharePoint document repositories and whatnot, but most of it was just files on shared drives, that people had been using for 10 years. This is when we pulled out of Iraq back in like 2010. There was a headquarters in Baghdad that had hundreds of people doing all nature of operations in Iraq. building schools to combat operations, uh, contracting, paying local contractors to do reconstruction projects, and over into the kidding military intelligence and whatnot. So human resources, there were uh, um, even though there shouldn't have been, there were personnel reports, all kinds of unstructured data, 40 terabytes of it. So we used a tool called active navigation to go through and to start mining through that data, telling us basically what we had. So we were looking at, the percentage of different file extensions, how many PowerPoints do we have? How much imagery do we have? How many videos are there? Excel spreadsheets. I mean, there's just an incredible amount of data that we had to go through and start to classify it. And then since we were prospecting, right, looking for the valuable stuff versus the non-valuable, there were lots of duplicates because people tend to get something over email and I better save a copy of this on the shared drive, and they do. And it turns out to be, even if they're different names, active navigation would identify duplicate files, and we would mark them for deletion. And sometimes you'd find 6, 8, 10, 20 copies of the same large file. So there was some of that element of it. We were trying to pare it down to the point where we could start doing something interesting, like machine learning. But mainly it was an archival data mining exercise. But like I said, we got a supplemental video if you want to learn more about it. But compared to data analytics, data mining is unstructured. You're not doing it to provide the most latest, greatest data on key performance indicators within your corporate strategic setting. It's really more exploratory. So analytics is more of an objective and to support decisions. And we've talked about this life cycle before. Data mining is part of data analytics, which is all subsetted under data science. Understanding the data. Data mining helps you understand the data that you have, and it could be companies buy out other companies a lot, and they don't even really know what they've got in the form of intellectual property. And text analytics, a subset of data mining, can start to shed light on that. Data analytics has more of a goal in mind. It's addressing particular questions, finding data that satisfies that, looks at the statistical significance if that is part of your model, and provides decision quality information to leaders. Mining is really more about figuring out what you got and what might be useful. Okay, so this week we got 2 assignments. We've got a discussion board. This one's really easy. You don't need to go nuts with academic references. This should be very conversational, which I'm always trying to get you guys to embrace. So pick 2 of these, paste the 2 into your response, and address them conversationally. And particularly the last one, how do you see a suitable fit for yourself in the future of data analytics? You may not want to do that one. Some of you are pretty hardcore application developers, and you may not get into analytics. But then you may. So there you go. And the other one is, we talked about last time, the research paper on a Fortune 1000 company. So do the best you can. There are often multiple articles on analytics at larger corporations like Walmart, Amazon, Wells Fargo Bank, Citibank, those sorts of things. So you're probably, in order to get enough literature to do a literature review, you're probably going to need to go with one of the larger companies. But try and get more than one article for sure. on any one company. If you can't find more than one article, it's probably you need to pick a different company and move on. But the Fortune 1000, the main thing, I hope people are listening. I hope people watch this. Fortune 1000 is not a company, although every semester, and it's different this time. This assignment is fairly new the way it's worded. But every semester, someone will turn in a paper that discusses Fortune 1000 as if it were Walmart or Starbucks. And they will say, Fortune 1000 company implemented big data analytics, blah, 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 blah. And there is no company called Fortune 1000 company. It's a list published by the magazine Fortune, like the Fortune 500. They publish that list, and it's based on sheer revenue. That's why Walmart's number one. They're not as profitable as everybody else, as some others, but they gross the most. I think they netted like 15 billion, 13 billion. But as we all know from the recent crash of the Dow, or the recent reduction, people are worried about profitability. Anyway, you need to find more than one article on a given company, and it needs to be within the Fortune 1000, which is every company you've ever heard of, virtually. So as you structure this paper, you need to cover these particular issues. All right. So the background, we'll just talk about, Walmart or Amazon or Toyota or whatever the case may be. And if you can find something that admits what they're doing wrong or a missed opportunity, please include that, what they're doing right, what they're doing wrong. Research questions, those come straight out of the articles. So you should describe, like, Smith 2021 posed the following research questions, and then you can you can use the direct wording. You can use a direct quote for that. And then methodology, that is something you can talk about in open text. What methodology did they use to study the integration of big data into an established business intelligence program? So list that for each article. So kind of go in order, right? When you're talking about research questions and you have 3 articles, discuss your first article first, second article second, third article third, and then go in that same order. When you're talking about the methodology, this should not be confusing. I should be really clear that you are talking about the same 3 or 4 articles in each one of these sections. If you craft your story correctly. And then, of course, the findings, they were going to analyze that data, right, according to whatever methodology. If there were hypotheses asked, did they accept the null hypothesis and reject the alternate, or vice versa? And if you don't know a null hypothesis from an alternate hypothesis, that's a good Google. That's the foundation of quantitative analysis. And then conclusions. Were they supported or not? What improvements can be made? And that's the often you'll see that in like suggestions for future research. So there you go. Big week, discussion and a paper due. So yeah, traditionally data mining and data analytics are subsets of the business intelligence or data science program, but data mining is definitely something that you kind of do in that analysis life cycle when it comes to understanding the data, knowing what you've got. As I said, I posted a voluntary supplementary video. If you are interested in clustering and classification in R, I posted that video. But again, it's voluntary. It's almost 3 hours, so it's kind of up to you. And as always, questions or concerns, just hit me up via email. Thank you.